Good morning, everyone. In this video, we're going to look at paragraph 7.3, and we're going to start with a pretty important concept actually. It's about something that we will call the angle sum. Usually, if this would be like a lesson in a class, I would ask all of you to draw like a random triangle, and then let's draw two random triangles just to show you something. I think this is still a fairly normal one. I'm also going to draw more. This is probably the one that Oscar would draw, I think. If you're wondering why am I holding a protected triangle, well, this is actually the second time that I'm recording this, and the first time I wanted to do this without, but I figured that I couldn't measure the angles of the pair of compasses, so I actually went over to the other classroom and fetched the protected triangle. So this is really small. This is what we're going to use. And we're going to measure every single angle, and hopefully you'll notice something. In this case, angle A is, let's see, 54 degrees. So angle A, 54 degrees. Angle B, degrees, and then angle C, and I can already calculate it, I can already say what it is before measuring it, because I already know that it will be 52 degrees, but I'm just going to measure it just to make sure. You can see 52 degrees. How did I already know that? Maybe you already have an idea about that, but if you don't, let's look at the other triangle before moving on. I'm going to measure angle D first, which is a pretty small angle. It's only 14 degrees. Angle E, let's see, it's 38. Then angle F, maybe we can already guess. My guess will be 128. Maybe that's somewhat cheating because I already know that it should be 128. Let's see. As you can see, 128. So how could I already know this? Well, think about these numbers, and at first they probably won't mean anything to you, but what happens if we try to add them up? The grid, so this will be 180. We're going to do the same thing over here. And that also gives us 180, and that's actually remarkable because we drew two completely random triangles, but if I add up all of those three angles, it's 180 in both cases, while the triangles were random. So how is that possible? Well, in math we have like a theorem, and it says, going to call it the angle sum theorem, and what does it tell you? All three angles a triangle together give you what? And probably when you measure this yourself, you're probably really close to 180 because you have like a small error in your measurements. But in general, when you're doing things really precisely, you will always get to 180. Okay, this is something that we're going to use right now. I'm going to erase this one. I'm going to make a random drawing again. Let's say that this one, angle BQR, let's say that this is a right angle, and let's say that this is 30 degrees. Then I'm able to calculate angle Q without measuring it. So how should you do that? Well, you know that angle B plus angle Q plus angle R should be 180 degrees. Why? That's what the angle sum tells us. Okay, let's assume that this is true. Then we already know that B is 30 plus angle Q, we don't know that number yet. A right angle, remember, is 90 degrees, always. So what should Q be? Well, these two things together are already 120. You want to get to 180, so you need like 60 more degrees. So angle Q is 60 degrees. And that should make sense because 30 plus 60 is 90, and 90 plus another 90 is 180. Okay? Is it always this easy? No, it will actually get a lot harder. Let's use this one last example, and I'm going to give you the following information. We're going to look at triangle KLM, and KLM is an isosceles triangle where KL is equal to LM. That's something they'll give you, and also going to give you that angle K is equal to, say, 40 degrees. Okay. Calculate angle L and angle M. If you want to do that, to do this without like a figure or a sketch is really difficult. So we're going to make a sketch. I'm going to erase this for now. I want a sketch of an isosceles triangle. What was an isosceles triangle again? A triangle in which two lines are equal. KL and LM should be equal. So if you want to make a sketch doesn't have to be perfect. It's supposed to help you. It's not supposed to be perfectly correct. So let's draw a triangle with two lines that are equal. About equal. Say that this is K. Now I have to think. KL and LM should be equal. So in our sketch, usually I tell you use the names counterclockwise. In this case, I didn't. When you're making a sketch, that's not important. The sketch is just supposed to help you. And I know that this angle over here is 40 degrees. So how am I supposed to calculate L and M if I don't know the other angles? Well, remember, in an isosceles triangle, that's the key to our problem, we have two lines that are equal, but also two angles that are equal. Remember, these are the two legs that are standing upon this base, which means that angle K is equal to angle M, because it's an isosceles triangle. Which means that angle M, we actually don't have to calculate it at all. You can just say, because it's an isosceles triangle, these two should both be 40. And now, basically, whenever you want to use the angle sum in a triangle, you need to know two angles and then you can calculate the third. So now we do know two angles and we can calculate the third one, angle L. So we know that angle K plus angle L plus angle M, that is 180 degrees because of the angle sum. And now we're going to calculate angle L, because it's basically 180 degrees minus these two things. Minus 40, plus 40 should be 100 degrees. Does that make sense that this one is 100? Well, in our sketch it doesn't, but this is correct with our story. 40 plus 40 is 80, 80 plus 100 is 180 again. So that's why this is correct. So keep in mind that whenever you're making a sketch should help you calculate the angles, but it should not be accurate. Or it should not, it's not necessarily that it's accurate. Because even though these angles are definitely not 40 and this one is not 100, the sketch is helping us in our calculations. Good luck, and if you have questions, just know.